Hi everyone, this is Matt Ingram with a review of the subset command, or what we've sometimes called subsetting. I'm going to go over virtually all of the examples of the use of the subset command in Pollak's R companion, the workbook, the R workbook that we've been using in course. As far as I could tell, there are a total of 6 guided examples in the R workbook. I'll go over 5 of them, the first few in greater detail, and then we'll move more quickly through the last few. So here in the window you should be seeing my R console. You can see my mouse moving here in a circle. This is the R console on the left, where the output will be excuse me, revealed. If I just hit return a couple times, I'll clear the whole screen. And on the right is the R script with all of the examples that I'm going to go over in this lesson. So every example covering the subset command is included in this R script and posted to our Blackboard site. All of these examples are from either Chapter 5 or Chapter 7 in Pollak's command. Occasionally I may zoom in or out of the lesson. If I zoom in, it'll look something like this. So here you see a zoomed in version of my R script. Again, you have this available to you, so you might want to go open the R script alongside this video and just make sure that you can execute everything as you're listening to the video. Again, all of the examples are from Chapter 5 or Chapter 7 in R. So let's start with this first example from Chapter 5. In this example, from page 61, Pollak tells us that we're setting out to explain or to understand what explains attitudes towards marijuana legalization. So in our classic hypothesis template, among individuals, we want to know what explains attitudes towards legalization, or more specifically, we expect that individuals with a certain political orientation will have different attitudes towards marijuana legalization. So in this example, Pollak considers 2 possible explanations. There are many others. We could have a long conversation about this, but the goal here is just to sort of set up this comparison so that we can execute the subset command. So the 2 possible explanations he considers are political orientation, that is whether one is liberal, say moderate, or conservative, and then whether one has kids, that is whether one is a parent. So basically we need to do a crosstab of political views and attitudes towards marijuana legalization, controlling for whether somebody has or does not have kids. To do the controlled crosstab, first we need to break the data set up into 2 data sets. That is, we need to subset the data. Here we're using the GSS data set, so we need to create 2 sets of data from the original GSS data set. This is what is achieved by the subset command. The subset command allows us to do this. So essentially, we want to be able, in the crosstab, to hold whether somebody has kids constant. One way we can do that is to create a data set where there is no variation on whether somebody has kids. Here we accomplish that by creating a data set with all of the individuals in this data set who do not have kids. So we take the full GSS data set, identify those who do not have kids, and basically parse that subset of individuals in the GSS dataset who do not have kids and move them into this new object or new dataset called kids.know. Similarly, we do the same thing, identify the GSS dataset, those who do have kids, and then subset that group into a new dataset called kids.yes. So let's come out from the zoom and just execute this first command. Again, you can do this multiple ways, but one of the easiest ways is to simply highlight the line and then hit Control R. So now we've created this. You can see this down in the lower left here. We've executed that command, and now we can highlight the second line and again hit Control R, and it's executed both commands. Again, if we're zoom into this area, we see our script up here. We simply highlighted these two commands, hit Control R, and in the R console we see them executed down here. At this point, we can now do the controlled comparison, right? That is, we can compare attitudes towards drug legalization, marijuana legalization across people with different political orientations while controlling for whether they are parents, right? Again, in the kids.know dataset, we can hold constant the fact that people do not have kids, whether people have kids, right? We know everybody does not have kids. And in the kids.yes dataset, we again hold that variable constant. It is no longer a variable, technically speaking, right? It does not vary, it's constant. Excuse me. And then we can examine the relationship between political attitudes, political orientations and attitudes towards marijuana legalization while holding parenthood constant. Since the dependent variable is measured at the nominal level, we know from previous lessons that we would use a cross tabulation for this. So this next set of commands basically executes those cross tabulations. I won't do those now. The main goal here is to focus on the subset command up here and to understand what that is doing. Another way you could understand what this has just done is to summarize each of these newly created subsets of data, right? So let's come back down into the R console here. We could type a summary kids.know, and let's just zoom in so everybody can see that clearly. Summary kids.know. This is going to summarize this smaller data set that we've created by focusing only on those individuals that are not parents. If we hit enter here, we'll get a summary of every variable in the data set, right? This is a very large data set, so you can see that there's lots of variables here. But we could go through, and essentially this is telling us variable by variable the profile of those individuals who do not have kids. We could do the same thing for kids.yes, and that would do the same thing. So we could do each of these commands, for instance, and go through and look for this grass variable. Excuse me. And look at the range. That's one way that we can sort of visually confirm, or just in a very cursory way examine the distribution of the values of attitudes towards marijuana legalization, just by quickly examining the distribution of that variable in the summary statistics for kids.know versus the summary statistics for kids.yes. Let's just get back down here and clear this out and get on to the next example. In the second example from Pollock, From page 64 in the R companion, the essential question is that we want to explain attitudes towards the Democratic Party. Right? Two possible explanations are again considered here. Income and sex. That is that your income, your level of income might explain your attitude towards the Democratic Party, and that men or women might have different attitudes towards the Democratic Party. So we need to examine the relationship between income and attitudes towards the Democratic Party controlling for sex. That is, we want to compare people of different incomes to see if their attitudes towards the Democratic Party vary while holding constant, while controlling for, holding constant the possible rival explanation of sex. In this case, because the dependent variable attitudes towards Democratic Party is a thermometer rating, that ranges theoretically at least from 0 to 100. It's measured at the interval level, right? So we use mean comparison to do the analysis. As Pollock notes, this turns out to be an interaction relationship. We don't need to know that right now in order to subset the data. So here are our subset commands. Again, we want to take our original data set, right, from the National Election Studies, that's the NES data, want to identify all of those people that are male, right, where the variable gender takes the value of male. And then we want to take all of those individuals now, all of the male individuals, male respondents in the National Election Studies data set, and create a new smaller data set, right, a new object called nes.male. We do the same thing for nes.female. We take the NES dataset, find the variable that identifies gender, find all of those individuals that are identified as female, so all of the women, and then create a new object or dataset called nes.female. Again, this breaks up the original NES dataset into two smaller datasets. If you combine them, they would form the whole NES dataset. But now we've got two smaller datasets, one that has all the men in it and one that has all the female. So essentially we're holding gender constant in each of these smaller subsets of data. We can then do a mean comparison here of attitudes towards democracy based on income. Again, not generating the plot, just as Pollock has suggested before, using NES male. Here, Pollock gives us a nice shorthand, right? Rather than having to write out nes.male $dem.therm and then nes.male $this variable. The with command is a nice shorthand that says basically with using this dataset, execute this command, right? Execute the mean comparison. And then again with this dataset, nes.female, cursor's not obeying. So with this dataset nes.female, execute this command. Just as an aside, a similar outcome could be reached if you use the attach command. An example is offered here, right? That you could say attach your dataset, in this case attach nes.male, and then you can execute this command without using the $, right? So for the dependent variable here, we don't have to write nes.male $dem.therm. We can just write dem.therm, the variable name, because we've already attached the data set. Right, so in R, you've referenced, attached the relevant data set, and now you can just use the variable names for that data set, dem.therm or income3.r. Similarly, you could attach the nes.female dataset and execute the same command. Again, these commands, this combination of commands of attach and then having the function that you're looking for, does essentially the same thing as this with command. if you tried this in your own on your own computer, you might have noticed that your R console tends to fill up with output, whereas the R console remains pretty clean, pretty clear with the with command. So you might have a preference for the with command. I have a slight preference for the with command. Unless I'm going to execute a long series of functions with the same data set, then I'll attach the data set at the very beginning, and then I might have pages and pages of commands working on that data set. I don't want to have to keep referencing the data set, so you can just attach it. Basically depends on what you're doing. Also, if you do use the attach command, please remember to detach it. Here's the command. You just detach, and then inside the parentheses you would put the name of your data set. So if you had attached nes.mail, here you would write detach nes.mail. Basically. Just like this. So that's the second example of subsetting data. Here we can go to a third example. I'll just zoom out because everything now should be a bit more familiar, but basically in this third example from page 65 in the R workbook, Pollock wants us to examine what explains attitudes towards homosexuality. There's a lot of different explanations, but two are considered here. Basically how liberal somebody is, and whether somebody has a family member or a friend who is gay. So either of these factors may affect one's attitudes towards homosexuality. So operationally, we want to compare attitudes towards gays across people who have different levels of liberalness, right? Controlling for whether they have family or friends who are gay. Here, because the dependent variable is measured at the interval level, we use again a mean comparisons test. And as Pollock notes, this particular relationship turns out to be additive. But essentially what we want to do, sort of stating it differently, we want to hold constant whether people have family or friends who are gay, and then examine the relationship between one's liberalness and attitudes towards homosexuality. So basically we want to take the NES dataset and break it up into two datasets. One dataset that has all of the people who do not have any family or friends who are gay, and another dataset that has all of the people who do have family or friends who are gay, and then examine the core relationship between liberalness and attitudes towards gays within each of those datasets. So again, we accomplish this with the subset command. Here, let's zoom in again just to see this a bit more clearly. And let me just separate this out so we can get a closer look at this. So here are the two subset commands. Again, we take the NES dataset, find all of those people who do have family or friends who are gay. That is, this variable that identifies those who have family or friends who are gay takes the value of yes. And we take all of those folks and put them into a new object or a new dataset called nes.gaysYes. Similarly, we create a new object or dataset called nes.gaysNo that contains all of those people in the NES dataset who do not have family or friends who are gay. That is, this variable sex1.orientation.familyFriends takes the value of no. So again, we've just taken the NES, the original full NES dataset, and we've broken it up into two datasets. The first one contains all of those individuals who do have family or friends who are gay, and the second one contains all of those individuals who do not have family or friends who are gay. We can then carry out the mean comparison test using the with command as before, with each of these data sets generating that controlled comparison. The next couple of examples move us to chapter 7. So this is the fourth example of subsetting, but it's not the fourth example in chapter 7, so be careful if you're looking for it. But it's on page 96 or 97, 96 through 97 of the R workbook. In this particular example, we want to know what explains attitudes towards reproductive rights, towards abortion rights. One hypothesis is that among individuals, Democrats are more likely to favor abortion rights than Republicans. And a second rival hypothesis is that education affects party identification, so it is really education that matters primarily rather than party identification. So basically we have two competing explanations, party identification and education. And the goal or the outcome, the goal is to explain abortion rights, right? That's the outcome of interest. So we want to examine the relationship between party identification and abortion rights while controlling for educational attainment. To do this, as before, we first need to subset the data. So we want to, as Pollock explains, we want to take the NES dataset and create two subsets of data from that NES dataset. One with everybody who has a low level of educational attainment and one that has a high level of educational attainment. And the cutoff basically is we've set at completion of high school. So this low level, this first subset, NES.LED, the L stands for low, so NES.low education comes from taking the NES dataset and then finding all of those individuals who have a high school education or less. So this variable education.R2 takes a value of high school education or less. And then we create a second object or dataset called NES.HED. The H here stands for high. So NES.high education is that subset of the NES dataset where this variable education.R2 took a value of more than high school. So now, again, just restating, we've taken the original National Election Studies dataset, the NES dataset, and broken it up into two datasets. One with those who have a high school education or less, that's the NES.LED dataset, and those who have a more than a high school education, NES.HED. Now we can do the crosstabs and chi-squared tests controlling for education just as Pollock examines. We won't do those here, but if you are interested, I've included the commands for them here so that you can execute those on your own computer. Example 5 of subsetting comes from page 98 in the R companion. I'm going to skip this one because it's substantially similar to the one we just covered. It's basically the same except you're using the survey design dataset, that is the NES-D dataset that you created in this chapter, instead of the untransformed NES dataset. So again, there is a fifth example of subsetting on page 98 in the R companion, but I'm skipping that because it's too similar to the example that we just did. The last example, example 6, is from page 99 to 100 in the R workbook. The goal or the motivation here is to understand, or the motivation in this example is to understand what explains attitudes towards gun control. Pollock provides us with two possible explanations to consider: sex and region. Again, there's multiple other explanations. We could talk about this all day long, but here we just want to set this up in a way that helps us understand how to test one explanation while controlling for another rival competing explanation. So we need to do a crosstab of attitude towards gun control, which is a dependent variable in sex, while controlling for region, that is, while holding region constant. How do we hold region constant? By creating a data set where region goes from being a variable to a constant, right? So we create two subsets of data from the NES dataset. The first one we're calling NES.NS, that is non-south, is a subset of the NES dataset where the variable south takes the value of 0, right? That is where it's not the south. It's the if you were to ask this variable, is this the south, it would say false or not true, right? 0. And then we create a second object or data set called NES.S. The S here stands for south. That equals a subset of the NES dataset where the variable south takes a value of 1. Again, what the subset command has done now is hold the region variable constant. In NES.NS, these are all the non-southern individuals. In the NES.South, these are all the southern individuals. So if we thought that somehow living in the south mattered for attitudes towards gun control, this is how we would go about holding that rival explanation constant. Now you can continue with the rest of the example, again using crosstabs, because the dependent variable is measured at the nominal level. Chi-squared and Cramer's V. Here are the commands below. I won't execute them, but I'll include them here in this R script in case you'd like to play with them and execute them on your computer. So that's the subset command. Again, here we've just covered 5 examples of subsetting data in order to reduce some variables to constants, essentially, in order to do controlled comparisons. There are multiple other uses for subsetting data. You might want to eliminate some observations and focus on a particular portion of your data set for an extended analysis. So if you have a very large data set with a lot of variables that you're not going to use, you might want to trim it down, basically. So create a smaller data set without those variables, or rather where those variables that take a certain value are the only ones that are included or conversely excluded. So hopefully these 5 examples have helped you understand the subset command. Again, the motivation for including this lesson was that in some of the homeworks there were some questions or problems, issues that came up with regards to the subset command. It's an important command to know, so hopefully this lesson helps you understand that. Again, this R script here is on Blackboard, so you can download it to your own computer and play with it on your own time. Thank you.